Good morning to all of you. We are live. Yeah, first of all, you tell me now, is the audio videos clear to everybody? Right. चलो आज का सेशन हम शुरू करेगा. So these are the ESC 2025 rankers from Unacademy. You can have a look at now. So these are the rankers you can have a look at. And so from GATE 2026 के लिए भी, so we started the test series. And the other new batches we are starting, you can have a look at. So Unacademy नया बैच भी हमने लॉन्च हुआ, क्रैश कोर्स, नक्षत्र बैच, and these many batches are running. So you can, another great feature of Unacademy is what I mean, Unacademy Una. With this, there are three type of modes are there: voice mode, quiz mode, smart summaries. According to the requirement, you can utilize it. You can ask the prepare a quiz on so and so topic in the particular subject, particular topic. Then it will create some quiz, and there is an option to select the level also. If you ask in the easy level, if you ask the, let us say, networks, so generate some problems on the Thevenin's theorem, it will generate some problems. Okay, like that. And test series is already live. You can see plus subscription as well as iconic दोनों भाई. You can choose according to your requirement. So iconic में क्या चीज एक्स्ट्रा मिलेगा आपको? 1-to-1 mentorship मिलेगा and physical notes भी आपको मिलेगा. ठीक है, right. चलो, let's continue our discussions. Last class we have discussed about this electromagnetic waves analysis हमने discuss किया, and the wave propagation through different type of mediums भी हमने discuss किया है, right? And we have did some problems also, and we'll continue the next topic now. Right? Next one. Skin depth. Skin depth, or we can also call this as a depth of penetrations. Skin depth, or we can also call it as a depth of penetration. Right. And what is the skin depth means what? The distance the electromagnetic wave travels inside the medium, inside the conducting medium, to get attenuated by 1 by E times of its original value. As we have seen this electric field amplitude, which is what you tell me now here, E is equal to E naught e power minus alpha z into cos of omega t minus kx, or we can assume this as kz. The wave is propagating z direction now, into we are calling it as ax cap. And the amplitude of this electric field, which is given as what, tell me now? The magnitude of electric field, which is equal to E naught into e power minus alpha z. What is the skin depth they are saying here? If we have seen this thing, the variation of electric field, how it will vary, you tell me now? It will. It is decreases exponentially like this. So if we call this is the z-axis, and here this is the electric field, and so this is z is equal to 0. When z is equal to 0, the electric field amplitude, how much this value? E0. This value E0. As the wave is moving along z direction, the amplitude of electric field goes on decreases exponentially like this. Decrease like this. And what is the skin depth means what? So after traveling how much distance, the electric field should becomes what? Tell me now here. 1 by E times of its initial value. If I say at this location, this amplitude is 1 by E times. Right. Now here this amplitude is 1 by E times of its initial amplitude, that is E0. And here the Z, which is equal to what? You tell me now? Delta. Z is equal to delta. So then this thing. So this points, when Z is equal to delta, amplitude will becomes 1 by E times of its initial electric field. Right. What are the coordinates of this point? You tell me now here. When x coordinate is a delta skin depth, y coordinate is how much the electric field is? 1 by E times of its initial amplitude. Now substitute these values here. When z is equal to delta, the amplitude will becomes what? Tell me now? 1 by E times of its initial amplitude. Now put these values here, so that is 1 by E times of E0, which is equal to, this is initial amplitude is E0 into e power minus alpha into delta. E0 will get cancelled. This is e power minus 1, which is equal to e power minus alpha into delta. So from this basis equal, we can equate the powers equal now here. Alpha into delta, which is equal to what? Tell me now? 1. So that means delta equal to what? Tell me now? 1 by alpha. This is the skin depth. Delta equal to 1 by alpha. Right? Now you can see now here. We got the skin depth delta, which we got it as what? Tell me now? 1 by alpha. For good conductor, what I can say? For good conductors, so we know this as alpha, beta, both values are equal. Alpha, beta, which is given as square root of omega mu sigma by 2. Omega mu sigma by 2. So from this we can say this as delta, which is equal to 1 by alpha. So that means also equal to, I can say, 1 by beta. So from this alpha, which is equal to, that is square root of 2 by omega mu sigma. 2 by omega mu sigma. From this, which we can write as what? Tell me now here? Delta omega equal to 2 pi f. So that is 2 by 2 pi f mu sigma. So 2 will get cancelled. So that is delta will come to be a what? Tell me now? That is 1 by pi f mu sigma. This is the skin depth. And you can see now how the skin depth is proportional. Skin depth is proportional to root f. And so here, as the frequency increases, skin depth will decreases. Frequency increases, skin depth will decreases. So, and the skin depth, which is also proportional to 1 by root sigma. As high conductivity, sigma is low. For in case of a good conductor, sigma value is very high now. The sigma value very high, skin depth is very low. Skin depth is very low. That means through the good conductors, the electromagnetic waves can penetrate very small distance. For good conductor, the penetration of electromagnetic waves is very small, which is almost in the order of the micrometers. In the order of micrometers. For good conductors, what we can say now? For good conductors, skin depth. So this is skin depth, which is in the order of skin depth is in the order of micrometers. That is very small. For ideal, so for the free space, how much the skin depth? For free space, how much the skin depth is? 0. For free space, skin depth, which is equal to how much, you tell me now here? 1 by alpha. Alpha is 0 now, so skin depth is infinity. And for lossless dielectrics, lossless dielectric means what, tell me now? Ideal dielectric. That means in this case alpha value 0 now, so that's why skin depth will becomes infinite. That means even the electromagnetic wave travels infinite distance also, the energy cannot becomes 1 by E0. So that's what we knew now. So the electromagnetic waves will propagate to infinite distance without any loss of energy. Okay. Huh. Right. Now we have seen the things now here. If we have taken a conductors, conductor, for this one, where the entire, so electromagnetic energy lies, you tell me now? And this is, if I say this radius is capital R. Now, due to the skin depth, where the electromagnetic energy will lies only in this region only. It can able to penetrate very small distance. Only this much of region only the electromagnetic energy will lies. Okay. Now you see this thing here, the resistance, what happens now here? R. If we call this as a DC resistance, what is the resistance formula? R equal to rho L by A. And so you can see now here A, and that is given as rho into length A pi R square na DC case. And if you are talking about the AC case, what happened? You tell me now here. Rho L by A effective we should call, where the electromagnetic energy lies only in the shaded part only. And how much this area you tell me now here. So this is a certain skin depth now here, and this is what tell me now skin depth, this value delta, and the length is 2 pi r. So this we can say rho L by, that is 2 pi r into delta. 2 pi r into delta. Now you can see now whose resistance is more, you tell me now. In this case, area, effective area decreases. If the area decreases, AC resistance increases. If it is increases, what happened to power loss, you tell me now here. Loss power, which is equal to I square into R now. So as the resistance increases, power loss increases. So as a result, I square R losses increases. So this is one of the disadvantage of the skin effect. So you tell me, as we have seen for conductors, conductivity is high, so the skin depth is very small. As a result, electromagnetic energy is confined to almost the surface of a conductor only. The confinement of electromagnetic energy to the surface of a conductor is called it as a skin effect. As a result of skin effect, the disadvantage is what, tell me? Power losses increases. As an effect of this skin effect, power losses increases. So because of that reason, for the amplification of the electromagnetic waves, we cannot use the BJT, the FET we cannot use. We have the special devices, that is for the microwave amplification we use klystron tubes. Have you heard these words? For the amplification of electromagnetic waves with klystron tubes or magnetron. Magnetrons are used for the amplification of electromagnetic waves. We cannot. Why? Because because of the high frequency, power losses are more. Done? Yes. Now let's see the summary of all the things what we have seen, all the parameters. Okay. Listen, first one by one parameters we'll see in detailed manner. You can see first one. So first we can say medium parameters. Medium parameters. And for the free space, mu is mu naught, epsilon is epsilon naught, and sigma value how much? 0. Okay. And lossless medium. So that is what we can say. We have mu r into mu naught, epsilon r into epsilon naught, and lossless medium sigma value 0. Low loss medium means what? Tell me now. Sigma by omega epsilon, which is very much less than 1. High loss medium means sigma by omega epsilon, which is very much greater than 1. High loss means good conductor. Low loss means good dielectrics. Now you tell me the next one here. Alpha, attenuation constant. Here for the free space, alpha value 0. Lossless medium is also alpha value 0. Low loss medium alpha is non-zero but finite value. So this alpha value, which is equal to sigma by 2 into square root of mu by epsilon. Mu by epsilon. Here this alpha value, high loss medium good conductor, that is square root of omega mu sigma by 2. Next here beta value, and beta value for the free space, which is equal to omega square root of mu naught epsilon naught. And low loss lossless medium, that is beta equal to omega square root of mu naught epsilon naught into square root of mu r epsilon r. Next, low loss medium. Low loss medium beta we have seen now, that is omega square root of mu epsilon. High loss medium alpha betas are equal, that is omega mu sigma by 2. Next, and phase velocity. Tell me the phase velocity Vp. And phase velocity Vp equal to omega by beta. So this will come to be what? Tell me now. 1 by square root of mu naught epsilon naught. And this Vp, which is equal to what we can say? Yeah, this is 3 into 10 power 8 by square root of mu r epsilon r. And this Vp, which is equal to what? Tell me. So in this case also, yeah, so 3 into 10 power 8 by, so square root of mu r epsilon r. Here Vp, yeah, we can write just formula, we can write, we'll substitute the terms later. Okay. Next. And what about the Vg, the group velocity here? In this case, free space Vg equal to Vp only. How much is value? 3 into 10 power 8 only. Phase velocity, group velocities are equal. Yeah, in this case also Vg equal to Vp only. See, the Vp is independent of frequency in a non-dispersive medium. That's why Vg, Vps are equal. Vg equal to Vp only in this case also. 3 into, no, so we should not write 3 into 10 power 8. This time we can write this. Vg equal to Vp only. But in this case, Vg, Vp are not equal. We'll write the formula we can write. That is Vp by, the relation is what? 1 minus beta into dVp by d omega. Right? Next. And we have a eta. And what about the intrinsic impedance eta? Eta for the free space, which is equal to square root of mu naught by epsilon naught, and which is equal to 120 pi, that is also equal to 377 ohms. And lossless medium, so that is eta, this is 120 pi into square root of mu r by epsilon r. Right, so that is low loss medium. So this is eta. It will also will come to be like this. 120 pi into square root of mu r by epsilon r. And here in this case, high loss medium, which is a complex in nature. So that is eta value, which is equal to square root of omega mu by 2 sigma plus j under root of omega mu by 2 sigma. It has a complex with inductive nature. Next. And phase difference between electric and magnetic fields. Phase difference between electric and magnetic field, E and H. Phase difference. Phase difference E and H, and which is equal to how much now in case of a free space, which is 0. Low loss medium is also 0. Yes, and for this high loss medium, which is equal to 45 degrees. And we can write this delta also, skin depth. Skin depth delta. Here the delta, which is infinity. Here also delta infinity. If the alpha, so here the delta is of finite. Delta equal to 1 by alpha. Alpha is finite now. And here the delta, which is equal to square root of 2 by omega mu sigma. Yes, copy this thing. If it is required, you can take screenshot also. Most of this will depends upon this table may depend करेगा most of the problems. If you want, you can take a screenshot of it. It is very much helpful. Done? Next. Yeah, tell me now. The intrinsic impedance of a good conducting medium is given by, yes, intrinsic impedance of a good conductor अभी ने देखा ना हमने. So here intrinsic impedance eta for the good conductors means what will be high loss medium. High loss medium, that is given as square root of omega mu by sigma into e power j45. So कौन सा option tell me now here? Omega mu by sigma j45. So option C. The skin depth in a good conductor is given at a frequency of 2 kHz. The velocity of EM wave in the conductor approximately. The velocity of EM wave. Yes, so here they given skin depth is given. So skin depth is what will be now delta, which is given as what will be now here 4 micrometers. Yeah, so you can see now skin depth for the good conductor, which is given as 1 by alpha. For good conductors, alpha and betas are equal, that is 1 by beta. So that means beta we can get now from this. So beta equal to what will be now 1 by delta, which is equal to 1 by 4 micro, 10 power minus 6. So this beta value, how much now here? 10 power 6 by 4 now. Now we need get what element of phase velocity Vp. Vp equal to what element of omega by beta. So omega equal to 2 pi f, 2 pi f by beta. Beta value 10 power 6 by 4. So that is Vp will come to be a 2 pi into f. How much is value? 200 kilo 4 by what we can say now 10 power 6. So that means Vp value will come to be how much? Simplify, how much will come? I think very small value will come. So this value, 5 zeros will get cancelled. So this is 4, 4 into 4, 16. That is 16 pi by 10. So this value, how much now? 1.6 into 3.14. So this value will come to nearly 5 meters per second. Next one. For the uniform plane wave of frequency 10 power 6 Hz propagating in a good conductor, the field undergoes a phase change in phase by 2 pi radians over a distance of 1 meter. The field is attenuated by a factor of 1 by E at a distance of. They given this as what frequency given and propagating is what tell me now in a good conductor they given. They given that field undergoes a phase change of how much now 2 pi radians for a distance of lambda. So we have a relation now that is delta x by lambda, which is equal to what tell me now 2 pi by so this is delta phi by 2 pi, delta phi by 2 pi. So delta x is 1 by lambda, delta phi is how much now? They given 2 pi by 2 pi. So from this lambda value, how much you tell me now? 1 meter. Lambda value 1 meter. The field attenuated by a factor of 1 by E times. Lambda we got, we need to get alpha value we need to get. That is skin depth we need to get. Yeah, so that means we got this lambda. We need to get the 1 by E times mean the skin depth is required. Skin depth formula tell me now delta. Skin depth is delta equal to 1 by alpha, which is equal to 1 by beta. Frequency is given now. How much is value? So we have a beta is equal to 2 pi by lambda. So from this beta will come to be a 2 pi now. And the skin depth is what tell me now? 1 by 2 pi. Okay, so option A. Next. An EM wave is propagating through the lossless medium having sigma equal to 0, mu r is given, epsilon r is given. Find the attenuation constant, phase constant, intrinsic impedance. Right. So an EM wave is given like this. They ask him to find what? Tell me attenuation constant, phase constant, and intrinsic impedance. They ask him to find. Let's try to calculate them. So this is gamma, that is given as what? Tell me now alpha plus j beta, and which is equal to what? Tell me now square root of j omega mu into what? Tell me now. Sigma plus j omega epsilon. That is alpha plus j beta, which is equal to square root of j omega. Mu is given as mu r into mu naught. Sigma value 0, that is j omega epsilon r epsilon naught. So then alpha plus j beta, which is equal to this is j omega into square root of mu naught epsilon naught, okay, into square root of mu r into epsilon r. That is alpha plus j beta, which will come to be a j omega square root of mu naught epsilon naught into this value. Both are same, will come 1 minus j2. So then it is alpha plus j beta, and which is equal to what? Tell me now. J omega square root of mu naught epsilon naught minus j into j square equal to minus 1, that is plus 2 omega into square root of mu naught epsilon naught. So from this we'll get this alpha value is what? I'll be now 2 omega square root of mu naught epsilon naught, and beta value omega square root of mu naught epsilon naught. Okay, omega value given, not given. If they given omega, we can get them. Next, so next one we need to get what? I'll be now here intrinsic impedance also. Intrinsic impedance eta, which is given as what? I'll be now. This is square root of, yeah, we can say this one. Sigma value 0, so we can say 120 pi into square root of mu r epsilon r. So eta will come to be a 120 pi. Both values are equal now, will get cancelled. So this is 120 pi only. No. Phase velocity of the wave in perfect dielectric is 0.4 times of its free space velocity. The relative permittivity of the medium is phase velocity Vp, which is given as what? I mean, 0.4 times the free space velocity, you can say c. Phase velocity, which is given as 3 into 10 power 8 by square root of mu r into epsilon r. This is 0.4 into 3 into 10 power 8 will get cancelled. So this is 1 by square root of, so this is epsilon r, which is equal to 0.4. So we will come it as square root of epsilon r, which is equal to 1 by 0.4. So that is root epsilon r is how much now here? 10 by 4 na? That is 5 by 2. Then epsilon r is how much, you tell me now here? 25 by 4. Next, A parallel plate air-filled capacitor has plate area given plate separation of 10 power minus 3 meters. It is connected to a 2 volts 1.8 gigahertz source. The magnitude of the displacement current is um, magnitude of the displacement current. Displacement current I is equal to C into dV by dt. They given these parameters or not? And plate area given, plate separation is given, connected supply is given, frequency given. Okay, we can, this time harmony form. So that is what I mean, J omega epsilon. So this is J omega C into V. Okay. And so this is ID, which is equal to omega equal to 2 pi f. Next, C is equal to epsilon naught A by D capacitance and V. So you can tell me now how much this value. So this is 2 pi into F. Frequency how much? So this is 1.8 into 10 power 9. Epsilon naught 1 by 36 pi into 10 power minus 9. Area into 10 power minus 4 by distance is how much? 10 power minus 3 into V value 2. Right, so simplify now. 10 power minus 9 will get cancelled, so this pi will get cancelled. And so how much we can write now here? This value 18 3.6. So this value we can say plus 1 banega. Now when it will go to numerator, so you can see this thing 2 into 10 power minus 2. So how much this value, tell me now? 20 milliamperes. Okay. Then it will becomes 20 milliamperes. Next one. They given E, they are asking to find the magnetic field. B expression they are asking to find. So that means E, which is equal to 10 cos of 10 pi into 10 power 8t minus 2 pi z into ax cap. So we can find the medium. So velocity Vp we can calculate from this. Vp is equal to omega by beta. This is 10 pi into 10 power 8 by 2 pi. This is 5. Right. 5 into 10 power 8. Now we need to get the B. Now B is equal to what we can say. We have a relation now E by B, which is equal to what element of Vp. So this is 10 by 5 into 10 power 8 into cos of 10 pi into 10 power 8t minus 2 pi z into direction, tell me. And direction, what we can say now, AZ cross AX. AZ cross AX. So simplify this thing. So this is 2 now. So this is B value come to be a 2 into 10 power minus 8 into cos of 10 pi into 10 power 8t minus 2 pi z into AZ cross AX plus AY only. So कौन सा option you to see? Option C. Next, for a ground in a rural area, epsilon r is given as 14, conductivity given at micro frequency of this much, it will act like a. So for that we can use the sigma, that is loss tangent. If the loss tangent we need to see. Loss tangent is very much greater, it is a good conductor. Otherwise, partial dielectric we can say. So tell me now sigma, they given 10 power minus 2 by omega value how much? 2 pi f. F is how much? 30 into 10 power 9. And this epsilon, how much this value? Epsilon r is given 14. 14 into this is 1 by 36 pi into 10 power minus 9. And you can see the cancellations here. Minus 9 plus 9. Pi will get cancelled. So this is 2 18s na. 2 7 2 9s. So will come to be a. So this value 9. 9 3s and this is 10. So this value will come to be a 3 by 70, isn't it? Into 10 power minus 2. So this value 3 by 7 into 10 power minus 3. This is very much less than 1 only now. So if it is very much less than 1, what we can say this is a, if it is high good conductor. So this we can say the dielectric only. And this is what we can say now here. This is a not a quasi-conductor, partial dielectric we can say. Right. Next. Pointing theorem. The pointing theorem is based upon law of conservation of energy. Law of conservation of energy. What this pointing theorem means? Consider we have taken one closed surface. Assume that the electromagnetic waves are coming from here. Electromagnetic waves are coming means they will carry the energy, and this electromagnetic waves are leaving from here. That means energy is leaving from here. Okay. This is the some closed surface we have taken. Yeah, you tell me now here. So how much the power leaving from my surface, you tell me now? The power leaving from my surface, which is equal to, how much we can say? P out. And which is equal to what we can say this as P in minus P losses. P in minus P losses, isn't it? Okay, P out equal to entry power minus loss power. And this final equation we can write it as what? Tell me now. This is closed surface integral of E cross H E cross H dot ds, and which is equal to minus d by dt of volume integral of 1 by 2 epsilon E square plus 1 by 2 mu H square into dV minus volume integral of J dot E into dV. This one. This is the Poynting theorem. Now you can see this thing here. P out means power leaving the surface. The net power leaving through any closed surface is equal to what? Tell me. The time rate of decrease in stored electric and magnetic energy minus conduction losses. So this term is called as a conduction losses. These are called as a conduction loss. So this is the total power leaving. This is called as a total power P out, which is equal to, this is the P in minus P loss. Understood the equation? Right? Now we have seen, now this is what this term is called as a 1 by 2 epsilon naught E square. This is called it as what? Tell me now. Electric energy density. This is called it as an electric energy density. How we'll get the energy from energy density? Joule per meter cube. So if we integrate now here, this is volume integral of 1 by 2 epsilon naught E square into dV. And what is this? You tell me now here. This is call it as a electric energy. This is the electric energy. And so similarly we can say 1 by 2 of mu H squared. This is the magnetic energy density. If we integrate with volume, then we can get it as what? Tell me now. Magnetic energy density. So magnetic energy. Okay. Now if we add these two here, we can get the sum of electric energy plus magnetic energy will come. Sum of electric energy plus magnetic energy. So this term, so which is P loss, power loss is what? I'll be integral of volume integral of J dot E into dV. This is called as a loss power, which is given as J is equal to sigma E, that is sigma E square into dV. This is called as a loss power. Okay. And if you see the left side term, and what the left side term we have seen, the term here we have seen, this is E bar cross H. And this term, which will denote this as a P, where this P, which is called as a Poynting vector. The Poynting vector. Vector means will have a direction. Na? So then what the direction of this Poynting vector we can say? That is E cross H will give what direction now? Wave propagation. Na? So the direction of Poynting vector is what we can say? The direction of wave propagation. the direction of pointing vector. Direction of pointing vector is along the direction of wave propagation. Okay. Now, and this power leaving the closed surface, that is P out, which is equal to what element of closed surface integral of E cross H dot ds, right? And this is the theory. While coming to the problems, what are the formulas we use, that we'll see here carefully, right? And we used to find this as an average pointing vector. Average pointing vector. Yes, so this will called as a P average, which is given as 1 by 2 real part of E bar cross H star, E cross H star. And this thing we will simplify, will get it as 1 by 2, that is E naught squared by eta into e power minus 2 alpha z into cos theta of eta into ak cap. And if we see the terms now, you see what is ak cap will give us direction of wave propagation. The direction of pointing vector is what direction is same as wave propagation only, na? That's why. So this will give us what will be now direction, unit vector, direction of wave propagation. Direction of wave propagation, ak cap. And this cos theta of eta, this is what you can say now, this is the power factor. This is a power factor. Next here, this alpha is what will be now attenuation constant. Alpha is attenuation constant. And right, E naught is a peak value of amplitude. Done. Now, if in case of a free space, what will happen? For the free space, what happens now? Free space. So this is how much is alpha value? 0. And what theta of eta, which is also 0 only now. Then this average power, which will come to be a 1 by 2, that is E naught squared by eta into ak cap. And in terms of magnetic field, we can write this formula as 1 by 2 eta into H naught square into ak cap. From this we can get the power density. Thereafter we can get the power. So power is given by what we can say. So that is integral of P average into ds. Then I can get this power will come. This formula similar to like a I square R V square by R we have now similar to like the formula. Okay, fine. Yes. Okay, that's it for today's session. And the next class will continue remaining. Okay then, see you. Bye bye.